In the last video, we talked about the rational roots theorem, and we used synthetic division. Well, there's a synthetic division shorthand. We're in 11.4b. And if you haven't seen the previous 9 videos for Chapter 11, you can just click in the description. The last one was really important. So you could get lost if you're trying to follow what I'm talking about if you haven't seen the last one. We talked about if a polynomial has integer coefficients, that there's a procedure for finding all of the rational roots, integers, positive and negative numbers. And the rational roots theorem pretty much said that any rational root of a polynomial is made by dividing a factor of the constant term by the factor of the lead coefficient. And that we can make a list of rational numbers that may be roots of a particular polynomial. And we use synthetic division to find the zero remainders, which proves the rational number is a root. And that sometimes none of them will have a remainder of 0, which tells us there's no rational roots. Okay, so as we saw in the last video, sometimes we get a very long list of possible roots. We could end up with like 10 or more, Even 5 is a lot. So that means we have to do a lot of synthetic division. Well, we can cut down on that list. We learned that polynomials with all positive coefficients will give us a positive value when a positive number is substituted into p of x, never a 0. So no positive number can be a root. Then we only concentrate on the negative factors of the coefficient when we do our synthetic division. Well, this fact helps us shorten the list of possible rational roots, but we still may have a lot of them to do in the synthetic division. So, there's a quicker way to do synthetic division. We just do the multiplication and addition processes in our heads. We do them mentally. And we need to fully understand the concept and method of using synthetic division for us to use this shorthand successfully. So, we've got our possible roots and our polynomial here. Here's our possible roots, and here's our polynomial. So, we've got p of x is going to equal this polynomial. And remember what I said in the last video, it could be f of x, it could be y. Don't panic about this. This is a polynomial, so I use p of x. We take the factors of this -4 and the factors of the 3. This is our numerator, this is our denominator. We end up with these possible roots, okay, from that rational root theorem. So we've got a positive or negative 1, 2, and 4, and we got a positive or negative 1/3, 2/3, and 4/3. So, using regular synthetic division, I'm going to go over this really quick so that it reminds you of what we're doing. We write our polynomial with just the coefficients. So we have a 3, a -11. Ooh, there's no x squared, so we've got to use a 0 as a placeholder. Then we've got a 10 and a -4. So we're going to use that for our synthetic division. And we drop our 3 down. We do 1 times 3 is 3. We put it here, we add these together, get a -8. We multiply these, get a -8. We add these together, get a -8. We multiply the 1 to this, get a -8. Add them together, get a 2. Multiply the 1 by the 2, get a 2. And we add it together, we get a -2. Now, we didn't get a remainder of 0, so we know that this is not a root of p of x. It's not a root of that polynomial. So let's try it again using -1. So, because that was our other choice, a negative or positive 1. We drop our 3 down, we do -1 times 3, we get -3, we add them together, get -14. We multiply these together, get a positive 14, add them together, get a 14. Multiply these together, get a -14, add them together, get a -4. Multiply this to this, we get a positive 4. Whoops, there's not supposed to be a line there. We get a positive 4, that makes a 0 pair. We got a 0 remainder. So -1 is a root of p of x. And because we got that remainder of 0 here, and it's a root of p of x, this is our new polynomial that we're going to use for the other possible roots. It's our quotient, that's our remainder, but it's also our new polynomial. So instead of using these values to check 2 and -2 and the other subsequent ones, we're going to use this as our polynomial. So we transfer it down here. We're going to try 2. We do 2 times 3. From dropping the 3 down, we get a 6. We add them together, get a -8. 2 times -8 is -16. Add it together, we get a -2. We multiply these together, get a -4. That gives us a -8. Nope, 2 is not a root. We didn't get a 0 remainder. We do this again for -2, and we get a -112 as a remainder. That's not a 0 either. So neither of these are roots of p of x. We try 1/3. I skipped the 4 because the numbers were just getting too crazy. So I tried going smaller to the 1/3, and we multiply 1/3 by 3 and get a 1, add them and get a negative 13. We multiply these together, get a negative 13/3, add them together, get 29/3, multiply these together. All right, we got a negative 7/9. So it's not a root. I tried negative 1/3 and dropped the 3, multiplied, added, multiplied, added, multiplied, added, and got a negative 10 1/3. Well, by the time I got to the 2/3, it worked. We got a 0 for a remainder. The 2/3 times the 3 made a 6/3, which is a 2. We added it, got a negative 12. Multiplied that, got a negative 8. Added that, got a 6. Multiplied them together, got a 4. We have an additive inverse. We have a 0 pair 0 here for remainder, which means 2/3 is a root of p of x. So now we know that negative 1 and 2/3 are roots of p of x, and that becomes our new polynomial, okay? Now look at all this work we did. Look how long this is, all right? We did all of this work, and we've got 2 roots out of these possible ones. And there's 2, 4, 6, 8, 10, 12 possible roots that we need to check. And we found 2 of them so far after doing all of that synthetic division. So there's a quicker way. Look at this. Look how short this is. This is the shorthand. All we're doing is the exact same thing we did here, except we're eliminating that line, this line right here. We're doing our multiplication and addition mentally. We only write down the coefficients of the quotient and the dividend. We say 1 times 3 is 3. We add it to the negative 11 and get the negative 8. So we're doing the multiplication and addition in our head and just writing down the answers. See? We get that negative 2, which is not a 0 remainder. So when we go to do negative 1, we're going to continue using this polynomial up here. We're going to ignore what's under my marker. So then we do it with this. Negative 1 times 3 is negative 3. And ignoring this line, we add it to that negative 11 up here. We get a negative 14. Then we do negative 1 times negative 14 and get a positive 14. We add it to the 0 and get a positive 14. So all we're doing is eliminating this line here. See? The second line, we have 1, 2, 3 lines. We're eliminating that middle one because we're just doing everything in our heads. Okay? When we come down and we do get the 0, this becomes our new polynomial that when we use 2, we use this one. And we ignore what's up here. See? The minute we get a 0, we ignore the upper one. And now we're going to use this. See? And we used it and came down and didn't get a 0 until we got to this point. And when we did, what we noticed would happen, this is the remainder 0, this is our constant, this is our x, and this is our x squared. So it would be written as 3x squared minus 12x plus 6 for our quotient, all right? That's our new quadratic factor. And we know that the factors of p of x started out as x plus 1 and this new polynomial we got. And then we found out that the 2/3 was a root, which means x minus 2/3 is a factor. So now we have 2 factors. And we ended up with this quadratic factor of p of x. And we can use the quadratic formula to find the rest of the factors. And we solved this in 11.4a. You can click on the description and watch that, all right? We just multiply and add in our head. And it's a lot easier if they're whole numbers or if they end up working out okay like the 2/3 did with the 3, all right? Our rational roots ended up becoming negative 1 and 2/3. And we ended up with the irrational roots of 2 plus square root of 2 and 2 minus square root of 2. You can watch the previous video and watch how we did that with the quadratic formula. I know a lot of you use calculators now, but boy, you know, we need to keep our students bright and strong in math, and I really hope that you learn how to do the quadratic formula with your own head without a calculator. Our next video is 11.5a, and we're going to talk about Descartes' rule of signs. There's 9 previous videos. They're all linked in this description. I'm going to add this to the Algebra 2 playlist. And I want you folks to really, really remember, and I know I mention this a lot, but nobody's listening. So I'm really begging you. You can help support my channel. If you like what I do and my videos are helping you, please help support this channel, help support me. You can go to my homepage and do YouTube fan funding for a one-time donation, or you can go to patreon.com/JoAnn School and become a monthly patron for just a couple dollars, all right? It's amazing that I have over 2,000 subscribers right now, and my Patreon is making $21 a month, and I'm trying to live on very little money as a grandma. So if my videos are helping you and you'd like to see me make more and continue to help without all those silly commercials in the front, please, please help support my channel, all right? Hit the like button. That raises the algorithm for JoAnn School, too. Or if you can't afford to donate, watch a couple ads. That helps me out with a couple pennies. I'll see you next video. I hope you have a great day. I'm proud of you. Keep trying. Bye.